Hi there, my name is Sam, and I'll be answering another question for Ask an Expert on Wyzant.com. So today we're going to be addressing a question involving the mean value theorem and monotonicity. In particular, we're going to be answering whether or not certain statements about those facts are always true or not always true. Now, the mean value theorem is a very neat theorem that tells you that the average rate of change between 2 points on a curve is actually represented as the slope of that curve at least 1 point between those two different points. And monotonicity means whether or not something is always increasing or always decreasing, or perhaps, remaining constant for some portion of the value of the function. So we're going to analyze each of these claims individually and see if we can determine whether or not they're always true or not always true. So A says if f prime of x is less than 0, in other words, the slope of a function f is negative, it's decreasing, for all x on an interval, then f is increasing on that interval. Well, of course, this is false because that's precisely the opposite of what the derivative being less than 0 means. This is false, not place, false, right? Because if the derivative is 0, if the derivative is less than 0, that means the function is going down. So it must be decreasing. This is false. If f is continuous on the closed interval from a to b, and it is differentiable on the open interval from a to b, then there exists at least one c in that open interval from a to b, such that the difference in the outputs is equal to the derivative at c times the difference of the inputs b and a. So in other words, what we could do is rephrase this so that we divide both sides by this amount. So we would have f of b minus f of a divided by b minus a. And this right here is the exact statement of the mean value theorem, which is a proven fact. And so if something is continuous and differentiable over an interval, then the average rate of change between the bounds of that interval is actually represented as the slope of the curve at some point between those intervals, between the endpoints of that interval. So this is true. This is the statement of the mean value theorem. C says if f is continuous on the closed interval from a to b, then there exists at least one c in the open interval from a to b, such that the same statement is true. Now, this is false because, and I presume there were meant to be parentheses here, just to be clear that we are dividing that entire difference by this entire difference. This is false because there is not an assumption that f is actually differentiable. There are functions, such as the Weierstrass function, that are continuous everywhere, but differentiable nowhere. They're just these super spiky, really infinitely complex looking functions that do not have any derivatives anywhere. And so this would not apply to functions like that. So the only time you can invoke the mean value theorem is when you know that something is not only continuous, but also differentiable over that interval. Since we're not assuming differentiability, this is not true all the time. And so we will say false. Letter D says, if f is differentiable and f prime is 0 for all x in the interval, the open interval from a to b, then f is constant on that interval, on the closed interval from a to b. Now, this is a trick question, because if something has a derivative of 0 for all values from a to b without including a and b, then that means it is actually constant between those two things. But it's saying that it's constant on the closed interval from a to b. Now, this is not necessarily true because we might have a constant function for every value between a and b, say it's always equal to 0 between a and b, but then at the values of x, a, and b, we might define the function to be equal to 1. In other words, if we include those endpoints in our interval and they have a different value from the constant function between them, then it is not constant over that entire closed interval from a to b, even if it is constant on the entire open interval from a to b. So given the way this is phrased, this is actually not always true, and so we'll say that it is false. And I should really say all of these false things should really say not always true. Not always true. And once again, not always true. In other words, this one should be always true. And for the last one, if f prime of x is greater than 0, in other words, the derivative is positive for all x in an interval, then f is decreasing on that interval. Well, this is precisely the by the way, I should say this one is actually always false. My mistake. If something is decreasing, then it cannot be increasing. So this is always false. And the last one is precisely the opposite of A. As opposed to saying that the slope is negative and therefore it must be increasing, which is false, this is saying that the slope is positive and the function is decreasing. This is also false for precisely the same reason, because it's simply the opposite of what it means for a derivative to be positive. If the derivative is positive, then the function is actually increasing. Okay, so that covers all of the questions relating to the mean value theorem and monotone functions. Thank you very much for watching.